Hi, my name is Lexi with the Lavender Town Project, and today we are going to be discussing paradoxes. So to first understand paradoxes, you need to understand the phrase dilemma. So a dilemma has one problem and two problems. That's two problems. Dilemma, twice present. So that's between a rock and a hard place. That would be a dilemma. But once you add a third option, that becomes a paradox. Para means distinct from, and dox means our opinion. So it's distinct from our opinion. So ironically, there's three types of paradoxes. The first kind is falsitical. It's false and it remains false. So I'm going to show you a couple pictures of triangles right now. Okay, so now that you've seen the triangles, you have one angle going inside and one angle going outside. So when you look at the triangle from a different angle, it becomes a different shape. But if you're looking at it from the right angle, it's a falsitical triangle. It looks like a triangle, but it's not a triangle. So it's false and it remains false. The other most popular thesis on falsitical is Achilles' tortoise problem. Okay, so by Zeno of Elea, which is this really, really, really old man from years ago. So here we have Achilles, and here we have the tortoise. So if Achilles lets this tortoise get like a 50-meter start on him, right? And then he starts the race. By the time Achilles catches up to where this tortoise has been, this tortoise has already left. So in his mind, he can never catch up to the turtle. And this is falsitical, because back then they didn't have an infinite understanding of that numbers can be infinite. So if we take 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/30 and so on and so on and so on, eventually we get to 1, where Achilles catches the turtle. He's just going to ride on the turtle because he's happy. There's our turtle. So Achilles catches up to the little turtle eventually. But does he? Because the turtle could go anywhere. So it's false and it remains false. And that is a falsitical paradox. Okay. So the third one is veridical. Veridical is false, but it has a perfectly good explanation. So for this example, I'm going to use a game show. So a game show. So you're in a game show, you pick box number 1. And you have a 33.3% chance of being right and a 66.66% chance of being wrong. So you have 1/3 being right and 1/3 being wrong. So say the game show host says he opens box number 3. And box number 3 was not the grand prize. Box number 3 was this messed up Z triangle thing. And so now you have 2 options left because 3 is gone. So would that make you still 1/3% right? Or would that make you 0.5% right? 50% right? Well, science says now you're 50% right. But now you're also 50% wrong. You're half wrong and you're half right. So with these 2 options remaining, with being half right and half wrong, where you're originally 1/3 right and 1/3 wrong, are you 33.33% right, or are you 50% right, or are you going from 66.66% wrong to an increase of 50% wrong? Did you start with the 33% chance, or was it always a half chance? And that is what we call a veridical paradox. It hurts your brain. It's false, but it has a perfectly good explanation. Most veridical paradoxes are words. So if I say this is an airplane, this is clearly not an airplane, right? But if I take this airplane, this piece of paper, and make it an airplane, it was a logical, obviously false thing. But now it's a obviously right thing, because now it's an airplane. So, that gets me to our third final paradox. Antinomy. It's not true and it's not false. Because it can be true, but it also can be false. It can't be true and it can't be false. So if I say I'm lying, would I be telling the truth because I'm lying? Or would I be lying because I'm saying that I'm lying? So that is the paradox that cannot be solved. Antinomy means, in Greek, anti, for against, nomi, law. For against law. It's just against the laws of your mind. It creates a crisis in thought right here. And it is used to explain all phenomena that cannot be psychologically put into a category of psychological stuff. So the most famous example of antinomy would be the grandfather paradox. So the grandfather paradox is saying, if I went back in time, and I found a time machine somehow before Tony, right? So if I went back in time, and I got this time machine, and then I took this time machine and decided to go back and kill my grandpa, then how would I exist if I killed my grandpa before he had my dad, and then my dad had me? So how would that work? Wouldn't I already be dead and I wouldn't be able to kill my grandpa if I was dead, because he wouldn't be there to create who I was. So that is an antinomy paradox. All paradoxes, like the turtle problem, were categorized as antinomy until they were solved. So if you have something that's false, or something that cannot be proved true or false, and then it's proved true or false, this airplane has a perfectly good explanation, but at one point it was not an airplane. And the falsical thing was a triangle, and it's still not a triangle. It's some weird shape, because triangles have to have all the edges connecting. And that is my explanation on paradoxes. Tune in next time for Lexi and the Lavender Town Project, where we discuss things all paranormal. And if you made it this far in the video, click that subscribe button and click that bell and leave a comment to save your grandpa. #SaveGrandpa. The end.